We are today having Dr. Ignasi Florensa Ferrando, who is our eighth speaker as part of the seminar series of the the 2024 semester. And he's a scholar from Barcelona, Spain. And I know him from 2019 as part of a 2-week intensive course on Anthropological Theory of Didactics. He was the organizer of this event, and I had an opportunity to learn a little bit about ATD research. So today also his talk will focus on Anthropological Theory of Didactics, as known as ATD. So and his title is Analyzing School Mathematics Through through Study and Research Paths, right? SRP. So this is a model for inquiry using ATD research. So as always, his talk will take about 45 minutes. And please feel free to drop your questions in the chat box, and we will address them during the final Q&A session within the probably 10 to 15 minutes in the end. After the talk, you can also unmute yourself and direct your questions to our speaker. So now I'm gonna introduce Dr. Ignasi Florensa. Welcome. And I'll just read his bio quickly and then leave the stage to you. So Dr. Ignasi Florensa is an accomplished academic and researcher holding a master's degree in civil engineering from the Universitat Politecnica de Catalunya, Barcelona, and he has 3 additional master's degrees. So he transitioning from a successful career in the private sector, where he specialized as a field civil engineer and project engineer. Dr. Florensa joined the Escola Universitaria Salesiana de Sarria, EUSS School of Engineering in 2011. So he's currently serving as the head of the university in the corporate and teaching innovation area, and his expertise spans various disciplines. So with a PhD completed in 2018, his research delves into the analysis of study process in higher education, particularly focusing on ecological conditions in engineering education and transition in mathematical education within the field. He actively engaged in certain international research groups like analytic simulations and inquiry in STEM and business education, as well as Anthropological Theory of the Didactics group. Dr. Florensa's commitment to academia is evidenced by his accreditation as a lecturer by the Agency for the Quality of the University System of Catalonia in 2019, validating a 6-year period of his research activity and cementing his impact on engineering education. So without further ado, I would like to leave the stage to you, Dr. Florensa, whenever you are ready.
Thank you very much. And first of all, I would like to thank the University of Southern Mississippi and you, Saida, in particular, for the invitation. As I was speaking with you in the previous moments of the talk, I'm very happy to have the opportunity to exchange with students and researchers from the States. As even if we live in a global world, it's not that common that we have spaces and opportunities to share, to exchange, especially researchers in STEM and in mathematics or engineering education from the United States and from Europe. And I think it's a very nice opportunity to exchange. I apologize a little bit for my English. I'm still forcing me to have a nice accent, but I'm sure that as long as the slides will start to move on, my English will be a bit complicated, but I will try my best. And sorry for the typos you may find on the PowerPoint. So that's as first thing. So when I was preparing the talk and Saida contacted me some months ago, I was as I was saying, very happy to be here and to be able to present some insights on the anthropological theory of the didactic, okay? And in particular, I think that it's relevant to present to STEM students, researchers, the proposal of study and research paths that are inquiry-based devices But not only, we don't see study and research paths, SRPs, only as as a teaching tool or a teaching device, but also as a research device. And I will get into that in the next slides. So I insist on that I'm very happy on this idea. I have structured my talk in two main points, and I will try to force myself to leave a nice space for discussion. So feel free to raise your questions at the end of the talk, and I will be very happy to start discussion. And if we have the opportunity to continue with some collaboration in the further month or in the next academic year, so I will be happy to collaborate. As you can see, I have two main points on the talk. First, I consider that it's necessary and important to highlight the role played by the theoretical approach which I frame my research, which is the ATD, the Anthropological Theory of the Didactic. Okay, so prior to present a more action-oriented device, which are study and research path, I will do an important part of my talk presenting the concrete and specific theoretical foundations that are at the base or that are the solid base where the study and research paths are founded. And I think that's important. So I will present this idea because I think that it's important to be very explicit as researchers to be explicit with the framework we work and the assumptions that we usually take for granted and leave on the implicit part. And I will try my best to make them explicit during this first part of the talk. During the second part of the talk, I will get on presenting this proposal of the study and research path, clearly an ATD proposal. And I will present the framing in this paradigm pedagogical paradigm where we are right now experiencing both in the school institutions from primary to higher education institutions. I will present SRPs and some experiences that we have been designing, implementing, analyzing with the ATD research group. And I will get specifically very into detail with one of these SRPs, which is related with a forecasting example. And I, as I said, try my best to leave some space for the discussion at the end. Great. So that's the plan for today. So let's start with this idea of mathematics education and didactics of mathematics. We have clearly an important difference at the level of vocabulary from the European researchers and states researchers. And that's something I want to clarify. Mathematics education is clearly this general term. I think it's accepted globally. And I think it's where mathematics education or maybe STEM education, okay, because as long as I work in mathematics, but also in engineering, I feel comfortable with this idea of STEM education. So let's say that STEM education, it's the global, worldwide accepted definition. So I frame myself in this path, but in Europe, we usually frame us in this part of didactics of engineering, didactics of education. So probably take that didactics as not as the classical word or the classical use for didactics in English, but something more in terms of study of the study processes of mathematics in engineering, etc. Okay, so I wanted to clarify these things. I like very much to start with this, what Yves Chevallard, which is one of the researchers that initiated the work within the anthropological theory of didactic, he always starts the talk what he calls the Humpty Dumpty principle. I don't know if you are familiar with Humpty Dumpty, but Humpty Dumpty it's a character from the book Lewis Carroll book, Through the Mirror, and what Alice found there. Okay, and there's a nice chat between Humpty Dumpty, which is this egg-shaped character, and Alice that I think it's important to pinpoint at the beginning of a talk, especially when the theoretical part is important. And let me read the quotation. When I use a word, Humpty Dumpty said in rather a scornful tone, it means just what I choose it to mean, neither more nor less. The question is, said Alice, whether you can make words mean so many different things. The question is, said Humpty Dumpty, which is to be master. That's all. So I think that we will find in the following slides and during the talk quite a lot of terms. And even if we use these terms as close as possible to the common sense, I think it's important to accept that they have a specific meaning when we work in the ATD. So I think it's important. Okay, I think that when we speak about theory, when we speak about some specific works within a theory, don't take them for granted. I will try to define the words I will mobilize during the talk. But I think that was an important point, that like detach from preconceptions and just accept the words I will mobilize. So as I was saying, a first thing that I think it's crucial to make a difference, at least when we frame our research on the ATD, it's this difference between teaching questions or the question of the teacher. We use it as it is the same, versus or in contrast to the research questions. And I think it's important. First of all, this notion of STEM education or mathematics education or engineering education is, as I was saying previously, this idea of a lot of approaches, a lot of research work addressing questions related or questions around the teaching and learning of a specific discipline or some knowledge at the crossroads of STEM disciplines. Okay, so we have this big term, mathematics education, that englobes this idea of a science addressing questions related to the teaching and learning processes of mathematics, science, technology, engineering, and at the crossroads of these disciplines. These general questions at the level when they remain very general, they can be formulated independently of any theoretical framework. And a good examples of these questions are, you have here two examples: how to teach functions in 10th grade, for example, or how to teach fractions at 4th grade, or which is the better way to introduce the negative numbers. And these are the kind of questions that a teacher in primary or secondary or even at higher education level might rise when planning a course. Okay, and these questions that can be formulated without a theoretical framework, such as these two examples, are for us teaching questions. Okay, so is that what they are not still research questions, because they are still far from be seen, let's see, with the Googles of a theory. And that's, I think it's important, this difference between the teaching questions, which are very relevant, especially for teachers preparing courses. And I think it's different from research questions that we will see in the next slide, what we understand as research questions. So in contrast to these general questions, the teacher question, when we take one of these questions and we assume this question as a research, and we start researching that, we need always, even if we don't have it explicitly, and I think it's important, we always assume a position as researchers. And I think it's necessary to do it in very explicit terms. So we all need a theoretical framework that will enable us as researchers to formulate new research questions. So if we take seriously that mathematics education, or in Europe, didactics of mathematics, or STEM education, or didactics of engineering, these disciplines, if we take it seriously, and I mean seriously, as we consider them social sciences at the level of pedagogy or sociology, then we have to be able to characterize systematically phenomena. Sciences deal with phenomena, and I think it's important. So we don't we accept that in chemistry, researchers in chemistry deal with phenomena that are described using a theory. The thing is that usually in chemistry, or most of the chemistry works are framed on a well accepted theory framework, but that's not the case in social sciences, and not even in physical sciences or in chemistry. When we get into the very small chemistry, or we go to the very special terms of, for example, genetics in biology, we have different theories explaining the same phenomena, and this is very common in social sciences. So to explain the behavior of a society, we have 3, 4, 5 theories that are accepted at the same time, and they are maybe complementing themselves. And we should be honest when we do research in mathematics education or in STEM education, and to accept that we need a theory, to be explicit with the theory we frame, and that helps us to formulate our research questions, and that's important. And to accept that we will have 3, 4, 5 theories at the same time living together, explaining different aspects of different phenomena. Okay. A nice way to illustrate that is this quotation from Guy Brousseau. Guy Brousseau passed away 1 month ago, and is one of the most relevant researchers in mathematics education in Europe. And he will develop the theory of the didactic situations. And he explains what I was trying to explain on the previous slide, much better than me, with this quotation. Didactics of mathematics, you can exchange for mathematics education, is a science. And if we take that seriously, Brousseau says, whose essential aim is to understand didactic phenomena, which then become both a construct and an object of study. So what do researchers in mathematics education do? We try to understand, to construct and study didactic phenomena. And I think it's an important thing. As in the same way that physics studies its own construct, physical phenomena. And I think that this idea of we study didactic phenomena is very important, and that detaches us. So as researchers, we face different problems from teachers. And I think that's kind of different and relevant. Okay. What is this idea of didactic phenomena? Let me get a second quotation and to define or try to frame a little bit better what we understand by didactic phenomena. Gascon and Nicolas, in a recent paper, define didactic phenomena as follows. No? Didactic phenomena exist. That is to say that there are phenomena which are genuinely didactic. That is, they are essentially appear in the development, genesis, teaching and learning, and diffusion of all kind of knowledge. And that's important. What they do mean by didactic phenomena and that they appear. The idea is that we cannot explain teaching, things happening, phenomena that happens during teaching and learning processes only by psychological theories. So because maybe we can explain a part of the phenomena that exists, but not only Psychology is not enough. Neither is sociology. Neither is semiotic. So there are some aspects of the teaching and learning processes that can only be addressed as a research question by didactics, by mathematics education as a science. And that's why we need to consider mathematics education as a science and not only as a sub-science of psychology, because psychology can explain some of the phenomena taking place during teaching and learning phenomena, but it's not enough to explain everything. As the same happens with sociology, with semiotic laws, and we have some phenomena that is specific of this didactic. Let me start to be more specific. I started very theoretically, I'm aware of that, and I will start to, let's say, landing in a more specific and more concrete things. Let me introduce a couple of examples of didactic phenomena. One that has been characterized in many works framed within the ATD, but from other approaches also, but this shared didactic phenomenon is what is called thematic confinement. That is very interesting, and I think it's a didactic phenomena very relevant for STEM educators. Thematic confinement is the conception of knowledge in schools, and when I speak about schools, let me be very, very general, primary, secondary, and higher education, but in school institutions, we usually have a conception of knowledge in terms of very different fields, and with teachers concerned exclusively on specific matters. And that hinders the possibility of many things that could happen. This, for us, researchers in STEM education, is a very relevant didactic phenomenon. And thematic confinement cannot be only explained by psychology, cannot be only explained by sociology. We need a specific science to deal with and to address these kind of questions. Another thing that is very relevant, another example of didactic phenomena, the institutional relativity of knowledge. We don't have a specific content that can be labeled in terms of functions. What we call doing functions is very, very different depending on if we are in a secondary school, if we are in a engineering university, if we are in a maybe business administration university, or maybe if we are doing research in functions. And I think that's an interesting idea. So we don't have a knowledge as functions. What is functions? What we call functions in secondary school, it's mainly given the algebraic expression, give me the graph. That's mainly what we do in secondary school with functions. But it's very different what, for example, consulting company might do trying to forecast the behavior of a stock market tomorrow. And both are working with functions. But the mathematical activity depends heavily on the institution where it takes place. So the name is not enough to characterize the mathematical or the engineering activity. Okay, so when we are in engineering course about structures, what happens in structures is quite different what happens at the workplace. And a lot of studies has remarked that difference between university practices and workplace practices. And that's why, because we have this idea of institutional relativity of knowledge. Okay, so the study of the causes, the possible modification, the characterization of didactic phenomena is what we do as researchers in education or in math or in STEM education. So I think it's important to highlight this phrasing here. Mathematics education does not intend to say how to teach a specific content. And I think it's relevant. What we want to do as researchers is to establish what didactic phenomena will arise given a proposal. If we teach, the idea is, if we teach fractions in terms of slices of pizza, which is very common, at least in Europe. I don't know if you do it also in the States, but as a part of a pizza, Yeah, and I take 2 parts of a full pizza that is cut in 8 parts, and I have 2/8 parts of the pizza. I will have, I will struggle as an educator when teaching, for example, multiplication of fractions. And that's what we state as mathematical education. Is that desirable? Desirable is very strong. So we as researchers, we can state these relations. If we teach things like that, these things will happen. Is that better or worse? It's not about us as mathematics or STEM educators to decide if what is better or worse. And I think the example, one example is very illustrative at this level of if mathematics education is or is not a normative science. So normative science meaning if the science can say what is better or worse. And I think the example is very relevant. And last year, Oscars awards learned us about the atomic bomb. So a nuclear physics can say what happens when we have a fission of atoms and how destructive it can be. But physics researcher cannot say if we can have to use or we cannot use an atomic bomb. This is a matter of ethics, moral considerations, and other aspects. But that's not a matter of the physics. So what we have is to separate us as researchers, as a scientists. We can say, if we do this, then that will happen. But what is better or worse is something about what role we attribute to the educational system, what is desirable in terms of values, is what is the citizen that might finish the secondary school be able to do. But this is not about mathematics education. This is about values, ethics, and I think it's interesting to separate and to consider us, even if we work in a social science, to consider us scientists. And that's what scientists do. Work with phenomena and to attribute laws and behaviors of these phenomena, but not to decide what is better or worse. And I think it's interesting. Okay, so getting a little bit into the ATD. The ATD is framed on what we call the epistemological approach, what we consider. And I think that the epistemological approach locates that the description, modeling, and reconstruction of knowledge taught existing in the school institution is at the core of the didactics research. In other words, and I think that's crucial for today's presentation, we consider, or the approach consider not only ATD, but other approaches, that the way we conceive knowledge is very related, is at the basis of these didactic phenomena. Let me make a very clear example. If we introduce negative numbers in primary and secondary schools, only based on models, which is, I don't know in the States, but in Europe, not only in Spain, but in France, Germany, Denmark, Italy, in most of the European countries, negative numbers are 20, 30 years ago, only introduced using models. Models such as temperatures, depths, altitudes, floors from a building. Yeah, and that's the way we introduce negative numbers. If we do so, what happens is that when we introduce pre-algebra and algebra, we have a strong didactic phenomena appearing, such as students have an important confusion with the minus sign. That is not only in algebra an operation as the opposite to the addition, but is an attribute to the number. And this difference, you cannot deal with that if you only present negative numbers as temperatures. And you also have a second didactic phenomena that is very relevant. You are not able to explain the multiplication and division rule of the signs. How do you explain that? -2 degrees multiplied or times minus 3 degrees is 6 positive degrees. It's impossible doing that only based on models. 40 years ago, negative numbers were presented as the way to respond to the need to solve first-degree equations that didn't have solution only with the positive numbers. So, for example, an equation such as x plus 1 equals 1, we don't have a positive number solving this equation. So that was how this was presented 30 years ago. And if you present negative numbers in these algebraic terms, the presentation of some pre-algebra and algebra to the secondary schools and the first years at university are different. You won't have these problems. Probably you will have other phenomena. That is, this is very disconnected, is not contextualized, and that will rise other phenomena. But that's an example of this dependence of negative numbers are only used to model temperatures, then you have problems. So the way you consider the knowledge, negative numbers are used to deal with depths, altitudes, or temperatures, then you have problems. So the conception of the knowledge is closely related on difficulties, problems. So the epistemology, the way you conceive what you want to teach, it's closely related with the problems and difficulties, what we call didactic phenomena, that you will have. Okay? So this is the main idea of the ATD, which has been developed from the decade of 1970s by Yves Chevallard as the first researcher working and developing the theory. And I think in that we assume this epistemological approach, and we have this idea of the content to be taught. Negative numbers as models to deal with temperature is not a given. We, as researchers, must question and modify the way the knowledge is conceived. Because if we want to modify, understand how didactic phenomena is change, evolve, or maybe overcome, then we need to change the conception of knowledge. And I think that's very important. And that fact contrasts very much, and I think it's very specific of ATD, because other approaches do not consider knowledge involved in study processes as an object of study. They consider it as something given, as something granted. They take that for granted. We have to teach negative numbers in that way, and this is not. We focus on other things, on how to teach, how to make students work together, which is relevant. But the way to conceive knowledge is also very, very relevant. Okay, let me skip some slides and get into the study and research path, because then I won't have some things. What is this idea of study and research path? We have this idea when we work on ATD, an idea of that we are currently experiencing a pedagogical paradigm shift. We are moving right now from the old teaching or pedagogical paradigm of visiting works, that's how we call, and is the prevailing paradigm currently enforced or being questioned, but mainly still enforced in school institutions. And it's the paradigm where study processes are very determined by a set of works to be taught. So we have to teach functions, fractions. Okay, so we have this in the curriculum. And we mainly, the teachers, structure, organize the teaching in terms of these works, and they structure and they do the didactic design in terms of these works that are mainly a list of knowledge to be taught, and that mainly remain very detached, even at the level of the discipline. Even inside mathematics, functions are barely related to proportionality. even if you take proportionality a bit seriously, is quite the same. So if you take proportionality, you can build on first degree functions. Why we never relate proportionality and functions in school institutions? It doesn't interesting question. So this thematic confinement I was speaking that hinder us to connect disciplines, STEM, for example, that we struggle to connect engineering, mathematics, and we have this thematic confinement. This is not only about the discipline, but also inside disciplines, we have this confinement. Okay. We also have this idea on the paradigm of visiting works that teachers guide the students through the knowledge organizations. They present a set of works, and probably, if we are quite lucky, we have a project or some problems in how to apply this knowledge. But this idea of problem-based or inquiry-based learning might remain still in a very application level. But we are just showing how to apply a specific piece of knowledge. And we will see that the new proposal, the study research path proposal, goes a bit farther. We will see. And there's also a problem. There exist numerous resources, textbooks, lecture notes that have been elaborated for centuries and for a lot of time, presenting knowledge in these very structured times. And I think it's important. Okay. For example, this is the classical structure of the first year course of mathematics for a business administration or for an economic major at the university. And this is worldwide. Okay. We have research works when we analyze these programs, and it's very interesting that even if the programs and the way they describe the course contents remain the same. So even if the program, the curriculum changes, what happens in teaching sessions remains very stable. And that's, I think, also an interesting didactic phenomenon. Okay. Two didactic phenomena that are very closely related to the paradigm of visiting works. We have monumentalism. So the introduction of new contents is based on a list of contents to be taught. So that's what we call monumentalism. Our sessions as teachers, or teacher sessions, are mainly a visit of monuments. We go to visit functions because they are important by themselves, but not because what they can deal with or the questions they are able to solve, but they are important by themselves. And we have this other phenomena, which is applicationism. In the old paradigm, we have very clearly, first we teach contents, then we show how to apply contents. And that's kind of the idea of that, this vision of mathematics existing independently of engineering or independently of physics or science. And that's quite an illusion, because you can't do mathematics without, so you can do engineering without mathematics, but the other way around is true also. So engineering makes mathematics advance. So it's not, this clearly distinction is not that clear. And the new paradigm characterized by the ATD is the paradigm of questioning the world. So Chevallard characterized in a talk in 2015 in the conference of the IGME 12, so the International Conference on Mathematics Education. He was the plenarist of this IGME 12 in 2015. And he says, up to a point, we might soon ditch the current didactic world in favor of a new paradigm, which, contrasted with the old one, the paradigm of visiting works, looks like a counter paradigm. What's this new didactic paradigm about? It's about any question has, we no longer address works, but we address questions. And we will consider questions seriously, and we will study questions in order to arrive to an answer, in many cases with help from our teachers. So the idea is moving from contents to relevant questions. And I think it's quite important. Okay. Study and research paths are both this research and teaching device. In what terms? In the idea of that study and research path is a way to make this new paradigm of questioning the world, the new paradigm of questioning the world, alive in schools institutions, and a way to move from the old paradigm, from visiting worlds to the questioning the world. I think it's this idea of study research path. So it's also a device to help teachers to address seriously questions with in the courses they are teaching, but also is a research tool to study how to taking and studying questions in school institutions modify some existing didactic phenomena. So it has this clear twofold character. SRPs start with more basic SRPs with what we call finalized SRPs, but this idea of finalized is SRPs that has an end, has a goal. So the question is chosen in order to teach or to make a specific content appear. So that's still in contact with the old paradigm or really open study and research path. When we choose a question to be studied because of its generating power. So with the capacity of this question to generate new questions, raise new derived questions, and to call for the mobilization of a net of important tools, knowledge that has to be studied to tackle the question. And of course, this idea that relates very much with the STEM education and study and research path, questions, if we take seriously questions are not enclosed in a given discipline. So if we take seriously how the stock market will move tomorrow, and we take this question seriously, we will have a huge number of disciplines involved in this question. We have economy, we'll have mathematics, we have social sciences, we will have a lot of disciplines running together. So taking the question seriously and addressing it by the students with the help of the lecturer will give us an opportunity to break a little bit the borders between disciplines, which are very attached or very related to the way to conceive teaching as a set of works to be taught. Okay? We have this idea of students, teachers, and a question, important and a live question. Yves Chevallard and our ATD research group, we don't speak about Googleable questions that you Google and you have immediate answer. But we need to search for real, alive questions, not just an excuse to find a very specific content. No, let's take real questions, okay? Together, students and teachers. And then we will, to address these questions, we will find some derived questions, so new questions that will help us. So, for example, taking this example of the stock market, how the stock market will evolve tomorrow. First, we have to speak a first derived question. What is tomorrow in the stock market? Do we have a tomorrow? Because when New York exchange stock market is closing, Tokyo is opening, then Shanghai, and then Berlin, and then Madrid. So do we have a tomorrow in stock market? This is a one derived question. So there's a lot of new questions. And of course, when we want to address these new questions, we will find works and answers that previously exist. Probably not directly to our question. That will have, but there are a lot of information, a lot of works, functions, for example, or functions or second degree functions or dynamic systems modeling, for example, for the stock market, no? That we can study and to see how to adapt it to our question. So I think it's important, this idea of the name of study and research. We research for new information, but we have also to study the information we find, and we take a moment to study, if you want, a more classical point of view of the teaching and learning process. And then we will construct, we will build this our answer to the question. Okay, important, by studying previously existing answers, by deconstructing and adapting this. I leave the letters and below because I will run out of time, and I don't want to run out of time. I have content. And this model of the study and research path can be used to describe small study processes, the study of a question, but also a PhD can be modeled in terms of I have a question and I study, I find partial questions. I have other works. Previously, researchers has studied this question, not exactly my question, but I adapt their work to get a partial answer. So it's SRPs also help us to model inquiry processes. Okay, so the idea of a research path, study research path as something cyclical, as taking into account a generating question queue, raising other derived questions that seem to help to approach that, searching answers or partial answers to these questions that are available in the what we call the media, so information, books, persons, internet, then deconstructing and reconstructing, so adapting and studying these answers to integrate to my questioning, elaborating my own answer and evaluating if this answer and is fits my initial question, and then getting new questions to open new study and research path. Okay, that's the idea, and I think it's important this part in the low right part of the slide, which is we study and research path, in contrast with other inquiry-based proposals, do not oppose to the study of knowledge. So we are not radical constructivists. If you take seriously the question of what will happen tomorrow with the stock market, you cannot pretend to find the answer you alone without getting connected to the internet, searching in books, contacting experts. And I think this idea of study and research complements in a very interesting way. Okay, so the idea of SRPs is to start with an open and real initial question. Okay, the idea is we don't have immediate answers, and an SRP, if we take seriously questions, we need time. We don't have this very short inquiry, only 1 hour session, but at least we are working, implementing study processes about 6 to 10 sessions of 2 hours minimum, and then sometimes more. We don't have a very clear pre-established path, but we as the teachers proposing that in courses, we have done an in-depth a priori analysis. We have analyzed where the question can lead us. And of course, a very new didactic contract will be appearing during the study process. We have to share responsibilities very differently. We have to plan the study, search for data, validate data, and probably the teacher is no longer the only validator. We need to agree if what we are doing makes sense or not makes sense. Okay? We will have clearly an enrichment of study activities. We will work collectively on the same initial questions, and students work in teams, usually under the teacher's supervision. Not all the teams addressing the same questions, but if we have a lot of derived questions, we have different teams working on these derived questions. Okay? I skipped this one. Here you have some of the examples of study and research paths that have been implemented from 2005 at University Autonomous of Barcelona and in different universities in Spain and in France. And you can see that from 2005 to 2023, we are still right now implementing a study research path that started at research devices, but right now they are quite stable and implemented, and they are no longer research devices, but teaching devices. And in very different disciplines, in mathematics degrees, but also in accountancy degrees, in statistics, in engineering, and in very different ideas. We have been working in dynamics of populations, trying to model the dynamic of bacteria growing in beer production. We have been working with students in transaction values in goods, sale, and purchase in accountancy. We have been monitoring water quality, energy consumption at the university in the campus. So one was with how to model, how to analyze the energy consumption at the campus, how to diminish the energy consumption, etc., and a lot of different aspects. We do not only frame in higher education, as I said, we have some in preschool for 4 to 5 years old students modeling the silkworms, which is quite classical experience to have silkworms in Europe, as we have a silkworms that will become a butterfly. So they model how many leaves of the tree they need every day at the level of 4 or 5 years old. In grade 3, grade 4, grade 5, they work with doing a baker box to fit in cakes. We also have been working in fashion. We have been working as we are monitoring if we are recycling well, analyzing which padlock is more secure, depending if it's numbers, letters, the different combinations. Okay. And this is leading to a whole new world of combinatorics in grade 9, grade 8, grade 10. Okay. And I want to finish, give me just 2 minutes to present one specific example. This example, we are presenting the experience at the first year of mathematics for engineers. And the question we raise is, we start with some news from newspapers. From 2014, there was a research developed by Princeton University in 2014 predicting that Facebook would lose 80% of the users before 2017. Okay. When Facebook heard about this study, Facebook used the same mathematical model to model the evolution of students at Princeton. And using the same model they used to model Facebook, gave this result. Facebook responds to Princeton study by predicting the school's demise. So the loss of students in Princeton. That's interesting. But it's even more interesting that in 2022, we have this new from The Guardian. It's Facebook loses the daily active users for the first time in history. And the question we raise to our students is that true? Is Facebook really losing users? And can you forecast Facebook users in 1, 2, and 5 years? And that's the question we raise. And that's very interesting because we have a lot of information. We have information on Facebook website. We have websites with raw data. We have the scientific paper of Princeton predicting the total loss of users for Facebook in 2017. And it's a very rich question that relates social sciences, population, worldwide population evolution, functions, data, and we try to force students to get into or to give a specific answer. What are the kind of answers they appear? What they mean about active users? And they discovered that social networks work with MAU, MAU, which is monthly active users. They work with daily active users. They work with yearly active users, and they monitor these variables, and they have to decide which is more interesting, which time intervals may be considered. Is this happening everywhere in the world, or it's something depending on the region? Do we have data? Where to find data? So what are the variables to be considered? And also how to make a forecast. We take functions and we try to fit classical functions. What does it mean to fit? Because we work with error. What kind of error is nice? And what is this error that Excel is giving me when I ask Excel to write to draw a line and to fit a line? Okay. These are the kind of questions we have in our mathematical courses of the last years of secondary school and first years at university. Okay, and we structure the question and answers in terms of question answer maps. That is what we have here, just a partial. But this is just an image. But if I click the purple ones, then I reopen it and I have new questions and I have new answers. Okay, and that's it. I'm done. I'm a bit late because it's 55. Sorry for that. But I'm open to questions, and I'm sure we'll run out of time. But I will be happy to answer questions by email or maybe arranging a call.
Thank you. Yeah, we have a few minutes. We have a question in the chat box from Mary. So she's interested to know how you became interested in didactic research, Ninkari-based teaching, and she's curious about the advantages that didactic, this research have.
Yeah, I can read on the chat. Very interesting questions. First of all, here I want to clarify this idea of when I speak on didactics, I'm not speaking on this idea of the stage of didactics. This is I take the card of Humpty Dumpty. The idea is didactics for me is mathematics education. So I'm not having this position of didacticism that is in the States a very teaching-led proposal. No. When I speak of didactics and when European researchers speak about didactics, we speak about mathematics, engineering, education. So this, I think it's important. So I'm not able to answer what advantage does didacticism has over student-centered learning. So as you can see, our proposals are quite student-centered learning, or maybe community-centered learning, considering the community, both students and teachers addressing seriously a question. Okay, that's important. So when I speak about didactics, as I said at the beginning, it is not about didactics as teaching centered, as mathematics education. So how did I become interested in mathematics education? So as Seida was saying when presenting my bio, I was working during 5-6 years in the private sector as a civil engineer, but I have been always very, very interested in teaching. It's something vocational. It's something that I felt always in my heart. But when I finished civil engineering and the master degree in civil engineering, I tried to, how to say that, to trick myself, to lie to myself, and to say, you have studied civil engineering, so let's go to work and give a try to civil engineering. Okay, but at the same time, after 6-7 years, I felt that something was missing by my side, and then I decided to move to teaching. And when getting into contact to the university, I'm now teaching and managing. But I realized I would need to study and to find a field of research to get into academia. And the main questions I had is how to teach and what is research and how different is to be a teacher or a researcher in mathematics education. And then I found the ITD group and the mathematics education group in Barcelona. I started to collaborate, and that's how I get engaged in this research. I don't know if that answers the questions that we had in the chat. I hope so.
Thank you. Since time is almost 1 p.m. in Central Time, so I would like to, thank our speaker for sharing his expertise on didactics and particularly study and research paths using some insights from anthropological theory of didactics. If you have any more questions, I'm sure Dr. Florenza will be happy to answer. You can reach out to him.
Feel free to email me. I don't know if you have my email, but Seida has. So, or I can write my email in the chat.
Yeah, it will be helpful since we are recording the session, so they will see.
Okay. Here you have.
Yeah. I want to thank each of you for participating at this seminar talks. And so this was our last final seminar. Again, thank you all for being here.
Thank you.